class. Okay, so first one. So let us just go for introductions of electrophilic addition reactions today. Electrophilic addition reactions. In this part, we will look at how the mechanisms, the relevant questions, how it will be coming for the previous JEE exams and all, and few practice questions I will be introducing in this class, right? So, who will undergo electrophilic addition reaction? Means we can say them as a alkenes, alkynes. So, first one, what is a necessary condition to undergo electrophilic addition reaction is a, we can say that presence of unsaturation is the necessary condition to undergo electrophilic addition reaction. Let us call the electrophilic addition reactions as a EAR. Okay. Now, before getting into their mechanisms and all, what are the different types of electrophilic addition reactions that we have to look through? Let us discuss. So, first one, addition of halogen acids. What does halogen acids means? Like HCl, HBr, HI in this case. Second one, halogenation. Next reaction will be a halogenation, like addition of Cl2, Br2, I2, and even you can say interhalogen compounds, like kaisa hota, like BrCl or ICl, like interhalogen compounds. This one. And next we have a hydration. Hydration means addition of water in this case. Next, coming to the fourth one is a oxymercuration, demercuration. Next, hydroboration oxidation. Next one is a hydroboration oxidation. Hydroboration oxidation. So mostly by this one. Next, sixth one. Sixth, sir, what are those means? Hydroxylation. Hydroxylation. So let us discuss all these electrophilic addition reactions. So this will be the thing we are going to discuss for the first 45 minutes of the class. Then I will be discussing some part of the physical content because it is an introductory class. Okay, now first one, we will be going for the mechanisms now. In this case, alkene, CH2 double bond CH2. So first one, let us define the electrophilic addition reaction. What is the definition for a electrophilic addition reaction? Electrophilic addition reaction ka definition. The reaction which is initiated by the reaction which is initiated by the attack of electrophile is electrophilic addition reaction. What does electrophile mean? Electron deficient species. Now, in this case, so first let us discuss about the CH2, CH double bond, CH2. In this case, the first, let us take a H plus as an electrophile. This condition, when this one will be a nucleophile. presence of unsaturation, pi electron, and this one will be a electrophile. Now, automatically in the presence of a H plus, the pi bond shifts towards the left. Therefore, this H plus electrophile will join over here, resulting in formation of a carbocation. Resulting in formation of a carbocation. Here we can check in other aspect also. Why it can't go towards the left side? Once if we check in this aspect, if this there is a possibility of this one also, here it will be minus and here it will be plus. Now in this aspect if we check, we are getting a, so this H plus joins over here and we are getting a 1 degree carbocation. This is 1 degree carbocation, which is a less stable. 1 degree carbocation is less stable, and this one will be more stable when compared to, this is not the most stable carbocation. 1 degree carbocation, say better stability will be the 2 degree carbocation. So in such a way the reaction proceeds, right? Now, let us look for a few more things. One, two, third one. CH3, 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 CH double bond, CH2 plus H plus. Try to form a best stable carbocation. In this case, what can we expect? This bond has to shift this side, minus and plus. So the formation of what type of a carbocation possibility is there? There is a possibility of a 2 degree carbocation. So 2 degree carbocation. This is a 2 degree carbocation. And please make sure a very important point. In any reaction, if carbocation is intermediate, we need to check its rearrangement. It is compulsory. Whether there is a possibility of rearrangement or not, we have to check for that. Now, in this case, let us check. This is a 2 degree. Is there a possibility of formation of a 3 degree carbocation, which is better stable? Right. So we have a, here the complete methyl group shifts, complete in the sense along with the bonded electrons completely shifts. Therefore, it is resulting in formation of a 3 degree carbocation. So this will be the, here it has to be 3. Yeah, this will be the thing. On it, later the nucleophile will attack. So whenever there is a possibility of carbocation, we have to check the stability of carbocation or rearrangement. Okay. So how this one we will implement in different questions, let us discuss for that. Now, so first, let us go for the reactions. First one is a addition of halogen acids. So how the reaction will happen? So first electrophilic addition reaction we are discussing, that is as per the list. As per the list, first one, electrophilic addition reaction. Let us discuss how different questions has come in earlier exams. That also we will be going through. Now, in this case, mechanism. Basic equation CH3, CH double bond CH2 plus HBr. We will be writing direct answer. How it will be, we will look at it in this case. So this is the equation we have. Now, let us go for the mechanism of this one. Mechanism CH3, CH double bond CH2 plus H plus. First step is the slow step. First step is the slow step. That one will be a attack of electrophile. After doing this mechanism, we will discuss the questions. So we have already checked. We will be getting this carbocation. Now, in this step, there is a possibility of a transition state. What is that? CH3, CH, single bond, CH2. Here there is a attack of H. This is a partial symbol, and this one will be partially plus. No need to worry about this compound. Iska detailed I will be making you in the equation page. This one CH, CH2. This is a slow step, first one. And next step, attack of nucleophile. Attack of nucleophile. CH3, CH plus, CH3. What is the nucleophile existing in the molecule? We have taken a reagent is HBr. That Br minus attacks on CH3, CHBr and CH3. Now, between the carbocation and Br minus, there will be a possibility of a complex. What is that? So CH3, CH plus CH3, Br minus will join to this one. Partial bond I am making over here. This is minus. So it is a partial negative. This is partial positive. So finally we'll be getting this one. Now in this case, this will be the this two is the mechanism steps. Now let us look for the graph, how the graphs will be in this case. Let us look at it. Graph point of view, mains usually they won't be asking you in mains. Advanced may they will be asking how we will make a graph for this question. Y-axis will be what? Potential energy. X-axis will be what? Reaction coordination. How we make this graph? So first, reactant. What is the reactant? Alkene. This one goes to the maximum energy. What is this one? We call it as a transition state. And next, it reaches to the carbocation. This is the first step. So what is this one? Let us take color. This is a TS1 I am taking. This is a transition state 2 I am taking over here. Now, this is a TS1. What is this? CH3, CH double bond, CH2 plus, H plus will be at the reacting point at this energy pay. Now these two will form a activated complex or a transition state. This one will be a unstable. Why it is unstable? Because it consists of a higher energy. Any species with high energy is a less stable. We cannot isolate this transition state. Please note that point. Transition state cannot be isolated. It exists for a fraction of seconds, and immediately it will be giving you the carbocation. This is a carbocation. So first step. Coming to the second step. Second step is a fast step. Fast step in this case, again, the carbocation with this nucleophile forms the second transition state, and it will form this one. This will be the product for us. CH3Br, this one. In this case, this carbocation, and this one will be a transition state 2. So graphical point, what are the more information we can draw from here is a, please make a note, this is a activation energy. Jada, more the activation energy. This is activation energy. For first step, this is the activation energy. More the activation energy, what will be the reaction? Slower will be the reaction. More the activation energy, slower will be the reaction. I can say this one. This is the activation energy. Greater the activation energy. Either you can say the left side one or a right side one, doesn't matter. So higher the activation energy, slower is the reaction. Slow step is the rate determining step. And for this reaction, what is the activation energy? This is the activation energy 2. Lower activation energy, fast reaction. So this is the graph how we make for the electrophilic addition reaction of halogen acids. Now let us go further. As of now, if anyone have a doubt, once I'll check you the chat. Sorry. Okay, chalo. Next one. Now look at the different relations of this one. So first one, halogen acids. So with that simple one question, we will be framing a n number of questions over here. Chalo. So first in this case, addition of halogen acids. In this, what is the intermediate? First one. So we have to note these key points. Carbocation is intermediate. So whenever carbocation is intermediate, we can say the reaction is non-stereo specific. We can say the reaction is non-stereo specific. Why? Carbocation is a sp2 hybridization. It is not 3 degree. So carbocation will be a sp2 hybridization. So therefore it is a planar one. So there is no 3D aspect. So you can say it is a non-stereo specific, and the reactions will be regioselective. What is that regioselective? I will let you know, and then we will proceed to the questions. Regioselective, first definition for the regioselective. The reaction in which if we get more than one product, if we get more than one product and the products has to be structural isomerism, and the products has to be structural isomerism. Structural isomerism in the sense what? I can say position isomerism. Position isomerism. So these cases, we can say those reactions are a stereoselective. Just with the basic equation, I will give you the example and clarify you this is regioselective. Let us take this one, and we are taking a HCl. What are the possible answers we can expect? We are making always secondary carbocation is more stable. So there is a possibility of this one. This will be of almost 90% possibility will be, because this is formed by 2 degree carbocation, and in a minor proportions, we can expect this equation also. So this will be 10%. So we got a two products in the reaction, and these two products are what? They are positional isomers. That's why we can say the reactions are regioselective. What does regioselective means? In a reaction, if you are getting the two products and the two products are related in which aspect? Structural isomerism aspect. That type of a reaction, you can call it as a regioselective. And what is non-stereospecific in the sense? Next, you will be getting much more clarity when we come to the stereospecific term. In this case, there is a carbocation as an intermediate, and you can blindly make sure the statement whenever carbocation is intermediate, the reaction is non-stereospecific. That is the point. So here in this aspect, we have a rule. What is that rule? Marconi-Kauf's rule. Most of you know this. Marconi-Kauf's rule in this case. So what the Marconi-Kauf's rule says? The negative part of addendum, and it is addendum in the sense reagent, you can say. The negative part of addendum is attached with the double bonded carbon containing less number of hydrogens. So this one is a negative part of a reagent in this Marconi-Kauf rule, this point. And Marconi-Kauf rule is applicable for which one? It is applicable for a unsymmetrical alkene. It is applicable for a unsymmetrical alkene. Unsymmetrical alkene. It is applicable for unsymmetrical alkene. Okay, chalo. Now let us make the questions over here. Questions related with the Marconi-Kauf's rule. Let us do the questions. Can go ahead with the question. HBr. Make a carbocation as an intermediate. This one. Then next Br minus will come and join here. So answer will be in this aspect. Any charts? Okay. Chalo. Coming to the second one. In this case, how you will be making the answer for this one? Yes, ma. In this case, so first you make a carbocation over here. The H will join over here, and the carbocation is 2 degree. Is there a possibility of making a 3 degree carbocation? Yes, there will be a hydride shift. Where is the hydrogen over here? Here. A pura hydride will shift. Once the hydride shifts, we will be getting which carbocation? This is a 3 degree carbocation. Therefore, this Br minus joins on the stable 3 degree carbocation. And this will be the answer for this. Chalo. Next, let us make another question. In this case, make it HBr or HCl, let us make in this case. So you will be getting a carbocation. The hydrogens joins over here. It has a more number of hydrogens. Now, in this case, what we expect? So there is a possibility of a formation of a 3 degree carbocation. So the bond completely shifts, and we are getting a 3 degree carbocation. Then after formation of the best stable carbocation, the nucleophile readily attacks over here. These are the cases. Now let us slowly increase the level of the questions here. Now coming to the fourth one. In this case, okay, I'll say this question in the fresh notes. The point where Marconi-Kaf's rule fail. Let us check in these points. What is that? CH3, CH double bond, CH2. In this aspect, if you answer Marconi rule, we expect that is Cl and CH3. But if there is a presence of, let us take an example, CH2, and here I am placing a one NO2 group, CH double bond, CH2 plus HCl. In this case, what answer we expect over here? This is a minus I group. Minus I group means what? Electron withdrawing group. This is a electron withdrawing group. What it will be doing? It will be pulling the electrons towards itself. The electrons are pulled towards itself. Therefore, the pi electrons shifts towards the left hand side. So we will be getting a minus over here and we will be getting a plus over here. Make sure presence of electron withdrawing group. The pi electrons shifts towards itself and H plus Cl minus. What the answer we can expect in this case? NO2, CH2, CH, and here the hydrogen joins and here CH2Cl. This is an answer over here. I have to make sure of it point. Important, this one. Okay, let us do a couple of examples over here. In this case, CH2, CH double bond, CH2. Let us place here aldehyde. Aldehyde is also minus I group. What will happen? The pi electrons will be pulled towards this. So we will be getting a answer opposite to the Marconi product. So this one will be CH2Br. Okay, in the same way, CH2, CH double bond, CH2. This is OCH3 plus HBr. Here also we will be getting a minus I group. Electron is pulled. So we will be getting CH2OCH3 plus CH2CH2Br. Till here is fine. Now the same question, CH. Let us make the CH double bond CH2. Please make sure. Important. This one I am giving here is a OCH3 plus HBr. In this case, what we expect the answer? ये क्या है? The lone pair. Here we have a conjugation. Conjugation means this lone pair has shifts here, this pi bond shifts here. In this case, the ether group shows a plus M effect. Plus M effect means what? Electron releasing tendency. Electron releasing tendency. In this case, observe it. So the OCH3 group is far away from the double bond. But in this case, this one you call it as a vinyl condition. This one we call it as a allyl condition. This is a vinyl condition. So oxygen lone pair will involve into resonance with the pi bond. So let us make the detail of it. CH3, OCH3. This one CH2 minus. This is the possibility. So the H plus joins over CH2 minus, and whatever the carbocation is getting, that carbocation will be stabilized. This is the most stable carbocation. This is a good stable carbocation. What happens is a lone pair can involve into the vacant carbocation. I said you carbocation is sp2 hybridization, means 1p is vacant. There are total 3 p's will be there. So 1p is vacant. To that vacant p orbital, this oxygen lone pair will involve into resonance and stabilize this carbocation. So in this aspect, we expect an answer in this way. So here we will be making Br and that one will be CH3. So this is an answer. Once check these two and it will be important. Okay. Once check these two. Chalo. Now, for the same question, if we apply CH2NO2 CH double bond CH2 plus HBr, we said it is a minus I group. CH2, already we discussed this question. CH2 CH2Br. Again, in this case, NO2. Observe this. Here, this one is a minus I group. Here, in this case, this one is a minus M group. If you have any doubt in this aspect, GOC aspect, you have to be very clear in this. How it will be NO2 and how it will be minus M and plus M. There is a conjugation over here. This is a vinyl condition. Ye to allyl condition. So we should have an idea of this GOC. Then we can easily predict the answers in this case. So what this one will do? This destabilize the carbocation, and being a minus M group, what it will do, the pi electron will shift here. Being a minus M group, the pi electron will shift here. So you will be getting CH2NO2 and the hydrogen gets add over here and this one will be. So in this case, you will be getting the same answer in both the reactions. In this case, we are getting the same answer. But in the earlier case, we are getting a different answers. Ek bar once check this one. Once in this case, check karo. Minus I group, here to plus M group. You are getting a Markov answer type. Here, this is a opposite to the anti-Markov answer we are getting. In this case, Markov answer. Because in this case, the OCH3 group is acting as a electron releasing or a donating group. When comes to in NO2 place, in NO2 term mein, both the conditions may it is acting as a electron withdrawing group only. So this is the key point for us. Now, electrophilic addition, further how can we check the reactions? Most important terms, these are what these are is a ring expansions. So this one is a ring expansions. So when we expect there is a possibility of a ring expansion, just make this keynote. The immediate carbon of the ring, if possess carbocation, then ring expansion possibility will be there. This is a point. Immediate of, sir, what does it mean? Now let us make sure in this. This is a 5-membered ring. Here, in this case, I have made a carbocation. So ring expands. This is a 4-membered ring. Let us take here immediate ring, there is a carbocation. Immediately ring expands. But here we should have one exception case. It is not an exception in this case. In this case, no ring expansion. I'll tell you the reason for that when we get back to this, when we come to this question. So first, please make sure this key point, immediate carbon of the ring, if it possesses a carbocation, then ring expansion takes place in electrophilic addition reaction. Now let us go for the electrophilic addition reactions. Chalo. Ring expansion cases equations. Let us look for a question. This is a 4-membered ring in this case, and we are adding a HBr. We know first you have to form a stable carbocation. Let us make the stable carbocation. Till here you might have a no issue. Now what happens further? Immediate ring has to open because 6-membered ring is more stable than 5-membered ring. 6-membered ring is more stable than 5-membered ring. Then 3-membered ring. Then this one 3-membered ring. What does it? Why it is the stability of a cyclohexane is more than this one means? Here, what is the hybridization of this carbon? sp3. Everywhere is sp3 carbon only. But when you check in this case, the angle is 60 degrees. But actually, if it is sp3 carbon, what the angle has to be? The angle has to be 109 degrees 28 minutes angle has to be. So sp3 carbon angle has to be this one. But in a cyclopropane, the angle is 60 degrees. In this case, angle is 90 degrees. In this case, angle is 72 degrees. Means there will be a ring contraction. So ring contraction exists with the ring immediately wants to break because of a high strain in the ring. So because of this condition, you might expect a doubt. So will there be a ring contraction also? Yes, there will be a ring contraction also. That cases as a special part we have to discuss for the ring contraction cases. So why the ring expansion is happening? Because you have to make sure due to the angular strain. Due to angular strain, the ring immediately opens. Now let us make sure in this case how this bond. Let us break the bond over here. I'll give you the numbering to understand better. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, this bond gets break. Completely shift this bond in this aspect. Chalo. Shift this bond in this. So how can we write this one? This one will be in this way. In this way. 1, 2, 3, 4, 5, 6, 7. So between 7 carbon and third carbon, there is a possibility of a ring breaking. So ring gets break. And which carbon is losing an electron? It seems. Once look at here at the third carbon, bond is getting break. Means third carbon will be getting a positive charge. Got it? So this is a what type of carbocation? Here also it is a 2-degree carbocation, and here this is a 2-degree carbocation only. Now let me write this one is equals to the straight one. I will write it 1, 2, 3, 4, 5, 6. Ye to 6-membered ring happened. This has become a 6-membered ring. So how we had made it? Now 1, 2, 3, 4, okay, 5, 6, 7. At the third carbon, we have a positive charge. Now this is what type? Two type carbocation. Now make a rearrangement of 3-degree carbocation. Rearrangement of 2-degree carbocation to 3-degree. Is there a possibility of 3-degree carbocation? Yes, there is a nearby here hydrogen is there at this place. This hydride shift takes place here. Therefore, what we will be expecting? We will be expecting the 3-degree carbocation. 3-degree carbocation. Now, on this, the Br minus attacks. So, how our answer finally it has turned into is this. Please make sure. Shall I repeat this one? If you are clear is okay. If not, so shall I repeat this? Text me if any. We will be discussing few more questions on the ring expansions. If you have any issue with the ring expansion, I have to look at. I'll do few more. Hello, Ramesh sir, are you fine with this ring expansions?
Yes, sir. Okay, sir.
Yes, sir. Okay, Murali,
Yes, sir.
Murali sir.
Sir,
Frank,
some
yes,
more
sir.
examples. Can you explain in the expansion?
Yes, sir. Yes, sir. Sure, sir. May I know who is speaking, sir? Murali Garu, right?
Yes. More explain.
Sir, example. This example you got it, sir.
Yes. I understood.
Okay, sure, sir. I'll write it that one in the next page. Please, okay, sure. So here now we will keep the more branches now in this one. Okay, let us go for another examples also. Ring expansion. Okay, last case we have discussed example is here we don't have a pipe, one methyl group. Now here we included a methyl group. So what will be the possibility in this case? Again, let us take first a HCl, like let us take a HCl1 in this case. Make a first stable carbocation. You are making a stable carbocation. Now let us give a numbering over here. 1, 2, 3, 4, 5, 6, 7. You might have a doubt, sir. All the time you are breaking a bond between uh, 3. This bond only you are shifting, sir. If I shift this 3-4 bond to this, will the say answer will be the same. So in that aspect also I will let you know. Now in this aspect, once check this one. So now let us elaborate. This is the thing. 1, 2, 3, 4, 5, 6, 7. So at the third carbon, we will be getting a positive charge. Why? 7 and 3 carbon bond is shifting towards the second carbon. Now, third carbon is losing its electrons. Therefore, there will be a possibility of a carbocation at the third carbon. Now you have to check. Is it a 1 degree, 2 degree, 3 degree? Here you got which carbocation? 3-degree carbocation. Now, in this case, we had a which degree carbocation? This is a 2-degree carbocation. You might have a doubt, sir, it is here, so 3-degree carbocation is there, right? Then why you expanded the ring? Because in this case, the ring strain dominates. The ring strain will be there high. So the ring strain tends to open the ring. Because of that, the ring opens. But finally, it is resulting to 2-degree carbocation. Now again, You have to make sure this one into a 3-degree. Is there possibility or not? Now let us check for this one. Now I will be writing the regular hexagon structure in this case. So here we have a 2 methyls. Now let me say 1. This is 2, 3, 4, 5, 6, 7 in this case. Now at the third carbon we have a positive charge. Now let us expect what will happen. The methyl shift, let us expect the methyl shift. So once the methyl shift happened, we will be getting a positive charge over here. The first carbon got shifted here. You can shift either the first carbon or this methyl also you can shift. Anything doesn't matter. Now you got a 3-degree carbocation. Once the 3-degree carbocation has formed, whatever the Br or Cl or I minus nucleophiles comes and attacks at this place. We will discuss more questions on the ring expansions. First, make sure you are clear with this. If it is possible, you can take a screenshots also. Yes. Like that, you can make a practice for a 4-membered ring. We can make a practice for a 4-membered ring or a 5-membered ring. Difficult ones, I will say. Try to make it for a 4-membered ring. Please check it. Try to make for a 4-membered ring, any one of you. I'll do here also one more. Yeah, please try to make it, sir. HI Karo. Quickly, I will make it. I'll do more examples over here. This one, ring expansion. Here, there should be an unsaturation. Double bond, compulsory. Ring expands. If you want a numbering, 1, 2, 3, 4, 5, 6. Draw it. This one. And here we have a positive charge. Again, we had an issue. We got a 2-degree carbocation. Now let us write the equalizing structure. What we got, that is a 5-membered ring. This one. So numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. At the third carbon, we have a positive charge. Now let us migrate the methyl group. So here, the one has shifted at the third carbon, 4, 5, 6. Now you got a positive charge over here. And that case, finally, we will be getting a answer. Ring question compulsory in JEE mains and advance or bits, any exam, it will be there. Ring expansion. So ring expansion aspect, only you remember one key point. Immediate after the ring, if there is a possibility, carbocation is there, ring opens, but not in case of cyclopropyl methyl carbocation. Now, once please go through these two, we will proceed to the further part of the lesson. Yes. So any ring expansion will be the same procedure. Any ring expansion will be the same procedure. Okay. Now let us do for a few more questions. I am proceeding with this. Try to do this. Electrophilic addition. Simply, we always focus on the Markovnikov rule. Electrophilic addition, the negative part of the reagent goes and attack to the double bonded carbon containing less number of hydrogen, like that. Right? All the time it won't be. No, you have to do the rearrangement. Please, can any one of you try this one? Here, CH2. And this is the question. Let us take HI. How you expect? Can any one of you try this? Is there a ring expansion possibility? First, you make a stable carbocation. First, let us make a stable carbocation. Yes. What is the stable carbocation? What is the first carbocation possibility? Chalo. Here this part, and here CH3, because H plus joins to the double bonded carbon containing more number of hydrogen. That point the basic Marconi rule point. Here you will be getting a positive charge. So here we have a positive charge. Now, do we expect any ring expansion? You might notice that, sir, it is anyhow 6-membered ring only. No, sir. How it will expand? Please make sure it is a bicyclic ring. There is a 4-membered ring over here. Please make sure. Hope you get that. This ring, this is the ring. Color. To this ring, we had a immediate carbon. There is a positive charge. Now let us make the ring expansion. Kaisa hota? Shift this. Completely shift this bond. Ye wala. And you are shifting in this case. So I can say make this one, and here it will be CH3, and here it will be H. On this, you might expect this, sir, it is a 2-degree carbocation. Is there a possibility of shifting over here? Is there any possibility over here hydrogen? No hydrogen, because this is a quaternary carbon. A quaternary carbon doesn't have any hydrogen, so you can't shift anything. So your answer finally will be same. This will be your answer, same thing. CH3Br. If anyone have a doubt, sir, here once this hydrate shifts from here to here, here positive charge, then from here it can come. No. Yes, that possibility is restricted. Why the possibility? Let me explain you that, and I will wipe it over here. In this case, this one will be CH3. Here we have a positive charge. Now let us hydrate shift. From here, try to shift the hydrate. Therefore, what will be the carbocation we are getting? Still we are getting a 2-degree carbocation only. Now, next, what you expect? Sir, here there is a hydrogen, right? This completely hydrate shift, if I shift, I will be getting a 3-degree carbocation. So, will this answer possible? Will this answer possible? So, this will be the carbocation. This is a 3-degree carbocation. As a theoretical way, we can say in this aspect. But here, the carbocation 2 degrees say it has to go to what? 2 degree to 1 degree to 2 degree, 2 degree to 3 degree. That is the successively the carbocation has to be more stable. But in this aspect, you are making a secondary carbocation 2, secondary carbocation 2, 3-degree carbocation. That type of carbocation rearrangement is restricted. Please make the note of the point. So that will be the answer for this question. This is an answer for this. Once look at the answer in this way. Chalo. 1 minute. Yes, sir. Oh. Hello. Yes, can any one of you can ask a doubt? I'll give you few more ring expansions also. Yes, sir. Kranti garu, Murali garu.
It's okay, no problem.
Yes, sir. Sir, if you are okay with this, then
Yes, yes,
Let us
yes,
practice one more couple of questions. Let us practice a couple of questions, sir. Yes. Try. This could be a bit difficult question. I won't prefer. Okay. This one as a trail you practice, sir. I won't prefer this question to be taught in the class. This one. So HBR. So when we are doing with HBR, I'll be giving the answer for this also. Just go for a trial for this. Sir, this could be the answer for this, sir. Just go for a practice of this question. Right. Just note down the question and have a practice, sir, for this. This could be the answer for that. Chalo. So once if you have got this one, no, this ring expansion, even in all electrophilic addition reaction, only these ring expansions we will be discussing. In all, like a hydration aspect, halogenation aspect, hydroboration, oxymercuration, these ring expansions only will be common in most of the books. Okay. Chalo. Next. So these are electrophilic addition reactions in this. Now, try to make the answer. All the time, make sure that you are creating a best stable carbocation or not. Yes, if it is forming a best stable carbocation, we are success in that case. Let us make a few couple of questions also in this aspect. So CH2, CH double bond CH2. In this case, let us take water all the time. I have not discussed about a hydration of water molecule. Even in hydration of water molecule, what can we expect? H plus OH minus, like a HCl H in this aspect. You can do hydration reaction. Though we have not discussed the hydration mechanism, the same mechanism it will have as the halogen acid addition. Make it carbocation. First, make the stable carbocation in this aspect. So CH2, CH plus CH3. So we will be getting a 2-degree carbocation. Is there a rearrangement? This there? Yes, we can hydride shift. Let us work on the hydride shift. Now, in this CH2 plus CH2, CH3. If anyone have a doubt, this is the best stable carbocation. Why it is a best stable carbocation? We call this one as a benzyl carbocation. And on that, the Br or OH minus will come and join. So why it is a good stable carbocation? Let us discuss. Sorry, here hydrogen will not be. CH2, CH3. Now, this is the answer for this question. Now, let us discuss the stability of benzyl carbocation. If you have an idea, that is okay. If not, so once have a check with this. That is a benzyl carbocation. How it is good stable carbocation. Right. Now, let us check with this. CH2 plus. We know that carbocation is sp2 hybridization. It has a MTP orbital. Therefore, what happens? There is a conjugation. Adjacent, we had a pi bond. This bond shifts over here. And this bond shifts to the MTP orbital of carbocation. We will be getting a positive charge. Now, let us write the ISCA resonance form. And you will be getting in this form. It is not, it looks odd. So this one shifts here, you will be getting a CH2, this one in this case. Again, there will be a further, more the dispersal of the charge. more will be the stability of a carbocation. This is also has to be the noted point. More the dispersal of the charge. Now what is happening over here? This bond will shift here, and here they will be getting a positive charge. Next case, this bond will shift here. You will be getting the molecule in this way. Once look at the first structure how it is and the final structure how it is. There is a throughout the benzene ring there is a conjugation, and this conjugation is extending with the carbocation. So like this, the dispersal or the deficiency of this carbon is compensated by the benzene ring carbons. For a time mean, the benzene ring carbons are bearing the deficiency of the benzene attached carbon. So this is how the stability of this carbocation will be. So in that aspect, you have to make sure. Now, based on this aspect, what are the different types of questions we can expect in this case? So next further extension question of this one is they will be asking us here, they will place electron withdrawing groups and electron donating groups. Then how our answer will be, we have to check. So basic model is this one. Now, if they change different groups on the benzene ring, or if they add different groups on the benzene ring, then what will happen? So for that aspect, let us do a few more questions. Now, in this case, let us make the question. Benzene ring, CH double bond CH, CH, okay, I will make it here. CH2, this one. Here I am using a NO2. NO2 kaisa hota? Double bond O, and here it will be a dative bond. And nitrogen will be having a 4 bonds, so they will have a positive charge in this. Now let us make sure. Now in this case, now let us do the same question. This one with OCH3, CH2, CH double bond CH2. Now you can do hydration, or you can do halogen acid, anything you can do, HCl, HI, HBr and all, anything we can carry the reaction, all are electrophilic addition. Now what will be the case? We have to make a carbocation. First make a carbocation, the benzene ring carbocation, CH2, you expect this carbocation, and this one will be 3. Now here NO2. Sir, it has to migrate. No, you said already there will be a benzyl carbocation is more stable. Okay, now let us make the shifting of it. And we are getting a CH2, CH2 this one and this one. And in this case, it is a unstable carbocation. Why it is unstable carbocation? This NO2 group acts as a minus M group. It pulls all the benzene ring pi electrons towards itself. Therefore, to its ortho position, it creates an electron deficiency. To its ortho position, it creates an electron deficiency. To its para position, it is creating electron deficiency. So this carbocation will be unstable in this aspect. Make sure the point, NO2 is a minus M group. It is a electron withdrawing group. It will destabilize the carbocation if carbocation is nearby the benzene ring. Therefore, what will happen? The answer will be against to the Markovnikov rule. So in this aspect, this bond shifts here. This one becomes minus, and this one will become plus, because in this aspect the carbocation has to be stay away from the electron withdrawing group aspect. So for that cases we are making a NO2 and CH2. Let's add H over here, and here your answer will be opposite to the Marconi rule. We are getting an answer. This will be an answer. When come to in this case, this one is a lone pair present on the oxygen itself. There has a possibility of involvement of resonance with the benzene ring. Therefore, this is a plus M group. It can stabilize the carbocation because of a plus M group. Therefore, in this case, the bond shifts here, and we will be expecting the carbocation has to be, you can shift here, you make a carbocation, in this case CH3, methyl shift, OCH3, this one CH plus, CH2, CH3, then anything, whatever the nucleophile you are taking, whether water means OH minus or Br. So that one will come and join in this place. So this type of questions will be expected. If you guys have any doubt in this aspect, sir, how it will be minus M and all, those all detailed will be in the GOC concept mein. General organic chemistry mein, those details will be. Once if you know about it, it will be a fingertips for you. It will be just a cakewalk of organic solving the questions. And this one OH2, and this one I am taking a Br, CH2, CH3. This one will be. So based on the GOC concept only, they have been framing a many questions for. But make sure organic is interlinked. If you are not clear with GOC or any structural isomerism also, if you are not good at, means it will impact whole organic chemistry, because recently advanced exam or mains exam also, no organic question will be direct. Organic questions will be link will be. So one equation say one equation, one equation say one equation, they will link. So each and every point we have to be careful in the organic aspect. So make sure these are the two. So like that we can discuss many things. So we have been discussing electrophilic addition only. There are ample of questions in the books. So we can practice those also. So Himanshu Pandey for advanced ke liye, or you can Avasti is also there. No, Avasti, that one. MS Chauhan. MS Chauhan is also a good book. Or Peter Skies. It is also a very good book. So these books usually you can. MS Chauhan is more preferred because you will get a answer booklet also for that. Okay, chalo. Now the one more question, and I will leave this electrophilic addition reactions. If anyone want to solve this question, yes, sir. Can anyone have a doubt? Means please ask, sir.
Sir, can you please explain me that anti-addition, syn addition?
Anti-addition, syn addition, right, sir? So that okay, sir. Yeah, okay, sir. Anti-addition, syn addition, you have a doubt in that, right? Okay, I'll make sure. Any more, sir?
Yes, sir.
So within 15 minutes, I'll make sure I'll clarify you for the anti-addition and syn addition part. So if anyone have a doubt, make sure of it point. Okay, sir, I'll do it. Now itself I'll do. Sir, now itself I'll do. You can please mute it because it is getting resound. Okay, chalo. So sir has a doubt of anti-addition. So first one, anti-addition, where we will be. So first, let us make for anti-addition is a halogenation concept. So let me make it clear. I will be completing this one fast within the given time. So halogenation concept. What is the halogenation concept? CH3, CH double bond, CH2. This is also electrophilic addition. Now in this case, I can add Br2, I can add Cl2, I can add I2, anything I can add in presence of CCl4. What is the CCl4 ka importance? CCl4 is just a solvent, non-polar solvent. Now, what will be the answer for us? So you are saying like, sir, it will be where the double bond will be there. That will be our answer. This is only our answer, fix. But how the mechanism and how can we explain this equation in a stereochemical aspect? Let us discuss. So few examples I will be giving you, and I will make sure in that Cl2 CCl4. How can we explain this? So just you will make this one. You won't be getting two answers. One answer itself we are getting over here. Chalo. Once I'll be giving you, and I'll make sure the mechanism, sir. I haven't seen your name. Okay, with the BR2, I'll make you clear and I will move. Don't worry. Yes, ये तो क्या है? BR होता. ऐसा way. Now, in this case, so how the mechanism proceeds? Let us discuss. Now, electrophilic addition reaction of, we are discussing halogenation. So, first one, electrophile initiate the reaction. This is the prerequisite points before getting into the mechanism you have to remember. Okay, next, carbocation is not intermediate. Sir, if carbocation is not intermediate, what is that then? Intermediate is halonium ion. Halonium ion. We call this one as a non-classical carbocation. Non-classical carbocation. So if carbocation other than carbocation, this one will be a non-classical. You will be understanding better when I get into the equation. Now, third one, fourth point, this reaction is a anti-addition. So this anti-addition type, what we call this one as a stereo-specific reaction. I'll explain the detailed word of this one when we do the mechanism now. This one is the point. Stereo specific. So you should be having the idea of these points. Once if you are just go through these points, we will discuss the mechanism and applications also, how you solve it, Sinne anti and all we will discuss. Within a 10 minutes we can complete, no issue. Chalo. If you are done with this, I am proceeding. Yes. Now let us do the mechanism. So step 1. In this case, Br, this one in presence of, they will generate a electrophile. This is the electrophile and this one will be a nucleophile. Now, attack of electrophile. Attack of electrophile. On whom? Alkene. Let us discuss this one. Okay, I'll make the 3-1 to make you better. CH2 plus Br plus. Now, where it has to form, the bond shifts here. Sir, why only bond shifts here means you will be getting a 2-degree carbocation. So for the reason you are making stability, or this bond can shift either here also, doesn't matter. So here you will be getting a positive charge and this one CH2 minus. To this minus, this Br plus joins. Once this Br plus joins, this positive and negative charge gets neutralized. Therefore, on bromine, how many electrons you will be having? 6 electrons, means 3 lone pairs. Now this lone pairs, you already know that carbocation is sp2 hybridization. It has a empty p orbital. So this lone pair will involve in bonding with the empty p orbital of the CH2 plus. Therefore, it is forming a intermediate. We expect that carbocation is intermediate. No, because the nearby bromine having a lone pair of electron. This lone pair of electron will involve into the bonding with vacant p orbital of carbocation. Therefore, bromine, this is formed. Now, in this case, it seems bromine is donating electron, right? So the positive charge appears on bromine. This is called as a halonium ion. This is the intermediate in the halogenation reaction. One side is completely crowded. Hope you get this point. Intermediate halonium ion. Sir, halonium, bromine is a halogen, right? I will write in place of halo, bromonium ion. I can say that. Anything is fine. Now, after this forming, one side is crowded. What it should happen? The Br minus, the nucleophile is over here. It has to go and attack on this one. So, where it will go and attack? On this side or on this side? We have to check that one. So, for this aspect, what we have to make sure is if this bond break on this side, okay, if this bond breaks on this side, here you will be getting a 2-degree carbocation. If you try to break bond on this side, you will be getting a 1-degree carbocation. Which is more preferred? We already know 2-degree. That's why this one will shift on this side. So your answer will be in this aspect. So this is the simple mechanism. Please, you make sure with the mechanism how we will work on this application questions. Let us discuss. Once if you are okay with this, so as a mechanism aspect, once you look at it, anti-addition, the incoming nucleophile, from where it is coming? On the opposite direction of the halonium ion. It can't come and attack on this side because downside there was a crowding area. So the nucleophile has to come and attack specifically from backside. That you call it as what? Stereospecific. It has to come from the PJ. That was a point. So mechanism associated with this one is this a simple thing. Now, iska related questions, how it will be, let us discuss. Once, please, if you are okay with this, yes, say, we will make the question. Any doubt in the mechanism? Hello, sirs?
Okay, sir. Okay, sir. Not,
Yeah, chalo. Yes, yes, sir. Chalo. Next, we are moving to the application questions. How it will be, sir, based on this. If you have a doubt, ma, please make sure. ये तो क्या है? Anti-addition. Anti-addition. So first point is a cis-alkene. Cis-alkene with anti-addition. Cis. You are doing bromine with the anti-addition. What answer we can expect in this case is a racemic mixture. We expect a racemic mixture as an answer. Transalkene with anti-addition. We are doing transalkene with anti-addition. What is your answer? We expect answer will be a meso compound. So first, only we are looking at this equation. Let us discuss about these 2 points. Now, in this case, this is a cis-alkene. You guys know it. And Br2, or you can say Cl2, anything, in presence of CCl4. What we will be getting? So the bromine attacks over here and here. What will be the answer you can expect? Ye to cis, ye to anti-addition. We expect the answer has to be a racemic mixture. H, I saw. This one will be a H. This one will be a Br, CH3. And even this one, it can be Br, H, and Br, H, and CH3. We can expect this one. Why? One bromine if comes and attack, no, another bromine has to come from the backside. So in that aspect, you will be getting this relations. Cis-alkene anti-addition, you will be getting a racemic mixture. Make sure this point. Okay, next one. What is it? Chalo. Next one is a transalkene. And you should have an idea of this one. They will be asking a many interlinked question of this one. So this one is a what? Ye to 50% will be, and this one will be 50%. So this, if this might be a dextro or levo, this might be a dextro or levo. We don't know that. Dextro or levo, how we identify? It is purely an experimentally we can identify it. Now in this case, this is a trans, this is an anti. And what answer we can expect in this case? Meso compound. Dekho, 1 carbon, 2 carbon, 3 carbon, 4 carbon. In this case, you don't have any carbocation, so no rearrangements. Directly, you can say this. Make sure the word, this is a stereo specific reaction. Why it is stereo specific? Because one side the halonium ion is formed, and another nucleophile is coming from the rarer side. In that aspect, you will be making a question in this. So J is advanced, they will be asking you how many products you will be getting and all. That type of a question we will discuss also here. Once please make sure this point you are okay. Means we will proceed to the next question. Chalo. Okay. Now exams they will be giving you questions in this aspect. Double bond. You are doing BR2. So how the answer has to be, right? A to BR, one has to be like this. What is your answer? In this case, in this way, we will be getting it. Once make sure this is the one. Sir, how it is means? And this is optically active, sir. This is chiral center. This is a chiral center. There is optical activity. You have to show the direction. How you show the direction? One bromine from the niche say. Let us take this one. Another bromine from top end say it will come. So you have to specify this in this aspect. Simply, if you write it answer in this way for this reaction, that doesn't make any sense because it is a stereochemical reaction. This is correct only. But how many answers you are getting? You are getting the 2 answers. These 2 possibilities will be there in the reaction. So like this anti-addition means because of a halonium ion, we are getting a anti-addition reaction, sir. So hope this will be. Actually, we have to discuss a physical session also. They have given us an instruction that I have to do 45, but it went only with the organic. Hope we wish you like the session. Okay, sir. Okay, sir. Hello?
It's okay, sir. Okay, sir. Okay, sir.
Thank you, sir. Thank you.
Yes, sir. Okay, sir. Thank you, sir. Bye, sir.